Okay, let's start down on this path of developer stuff. So I'm not going to talk about, okay, everybody's seen that. Let's just move on. Okay, so where do you start? I'm assuming you're interested in, as a developer, since that's the title of the thing, if I'm going to write code for SQL, want to leverage features of SQL, where do you go? And so the place to start is you got to go pick up SQL Server Developer Edition. Currently, the SQL Server 2016 SP1 Developer Edition, it has all the features of SQL. It is free. You don't have to pay for it. You might have to give a fake name and email address to get past the gate in the website. But this is where you go. And then you can download it and install it, and off you go. You have access to all the features of SQL Server. I don't know why people don't do this more often. Like, people will go and download Express Edition because it's free to play with. And I'm like, well, you can get the whole thing if you're just going to go play with it. So get the real Developer Edition. It has license limitations, as in you're not supposed to use it for production. You're not supposed to deploy it and run production workloads. But as a developer, you want to write code, you want to play with it, you want to test stuff, just pick it up and go with it. So you go to the Microsoft.com/SQL Server, and then you can download this. If you want to play with the next version, then you can pick up the CTP 1.2 of SQL Server vNext, which is available as of today. It comes out every month. So 1.2, 1.3, and then at some point it becomes 2.0, 2.1. So the next version of SQL Server is already in technical preview. That you can download and install to use on Windows, or you can install it on Linux. So if you were in a previous session when we talked about SQL on Linux, so again, the CTP has all the features, so you can experiment with and play with. If you want to install SQL Server on a Mac to play with, then you can pick up a Docker image of SQL Server and install it and play with it. So that's where you start. The documentation is easy to find. And you'll find that these days, all of the stuff has, below the documentation, you can provide feedback, and you can actually post questions to the forums. As a developer who wants to play around with SQL Server, if you have questions and you don't know what to do, or you run into stuff, you can go post things to forums, and engineering organization is continuously monitoring the forums. In fact, we have some automated systems that go scrape various forums and Twitter feeds and find questions about SQL, and then we get email digest of the questions that exist. So one of the good places to go ask questions if you want to know how to do something and write code in SQL is Stack Overflow. A lot of SQL experts. For Stack Overflow, we try to play slightly more in the background role, because that community is really the community helping the community. So if we know that there are experts and MVPs, and we let them answer, but if something goes unanswered, then we'll jump in and answer it. If you post questions to Microsoft forums, then we will answer it immediately in the documentation section and whatever. If you go to Hacker News and post stuff there, we will try to answer it. So if you run into problems, don't spend too much time. Just go ask, and you'll get an answer. The SQL forums on Stack Overflow are very, very active. And just so you know, Stack Overflow is built on SQL. They use SQL Server 2016 with Always On to run the entire thing. So anyway, so this is where you start. Now, I'm just going to talk about some features which we think are good features that developers should use to build applications. I'm not going to talk about DBA-related things in this session. And I'm also going to depart from the normal way we run this session. Is usually I talk about the feature and the scenario, and then I get on here and do a demo, like write some code. And I decided not to do that because I'm not sure it's very interesting watching me here doing stuff. You're sitting there far away. So I'm going to actually go do walkthroughs of where the samples are and how do you get them, and go through that. And maybe that would be more useful in providing you the information for you to go play with it, because watching me doing stuff here, I'm not sure is as useful as you out there playing with it. And you have my email address. You run into trouble running the samples and whatever, my entire team will help, because they're the ones who are responsible for writing the samples. So if they're crappy, right, they get called on it. So let's start with JSON. Everybody probably knows what JSON is, and there are databases that support JSON. And in SQL Server 2016, we have JSON support. JSON is everywhere, and now we have JSON support in SQL. But what exactly does it mean to support JSON, and what can you do with it? So the use cases are usually, service integration, data exchanges, people who want to have some flexibility in the schema. There's a lot of use cases for JSON. And so if you have a database that doesn't know what to do with JSON, you're probably going to be, not looked favorably by developer community. So, and we took a lot of beating for not supporting JSON. But we had a lot of battle scars from XML. Like, we did all this XML work that nobody used. So we were a little more cautious with JSON. But it seems like, JSON is popular, it's being used, so we're supporting it. So we don't have a native JSON type. Like when you store stuff, you don't actually store JSON. But what we have is the ability to go from row to JSON, JSON to row, right? And if you store JSON as a varchar, right, then you can actually pull it out and parse it and work on it. And we'll look through it, right? I don't know why that last line is there. That's bad. JSON is supported on Azure SQL DB and SQL Server. So that's my bad. So JSON in action, if you have JSON, then you can do table to JSON, JSON to table. And that's usually what people want. You have records in a database, and you want to produce JSON because you're going to send it to some other app that takes JSON as an input. So you could use that. So transform JSON text to table. And this is what it looks like. So we have the open JSON functions. That row turns to JSON, and you can define a JSON type, which is a text, and then turn it into row, right? It's fairly simplistic, but it works pretty well, and it's pretty fast, and it basically frees you from having to do the parsing yourself, right? Now, we're taking feedback on this stuff continuously. So where can we expand? Where can we add to make life even easier? And we're open to hearing from the community. It's like, no, we really do want to have a JSON type, which at the end of the day, basically hide the fact that the thing is JSON and it's stored, right? We'll be interested in knowing what the feedback is. Anybody has used JSON? Write code for it? All right, so you can shout your opinions about it, right? So then you can do queries with for JSON clause from the table, produce JSON. Again, as you can see, that's what it turns to. And then you can also do some indexing with that method that you see up there if you need to index fields. So this is the gist of our JSON support. Yes? Yes. Yes, I believe so. Yeah. Now, we have a very, very active team that works on JSON. We actually have a little engineering team in Serbia. And they're very active in producing Channel 9 videos and YouTube videos about their work. So if you go to Channel 9, search for JSON, you will find at least, 5 or 6 presentations that go in the depths and the details of it, right? So again, in the spirit of enabling you to go out there and succeed, that's where you would go. For most of the stuff that we do, there's a Channel 9 video on some of the technical aspects of the features. So now, instead of sitting here and writing code to show that I can write JSON code, I'm just going to go to our GitHub repository. If you look here, we pretty much these days throw everything in GitHub. So github.com Microsoft SQL Server samples. If you go there, and let's just go click on it. And here's the JSON samples. So any presentation we do, any demos that we write, and any sessions that we present, we just package it up and push it to GitHub for people to go use, download, improve upon. So let's pop up. So from feature perspective, you can see these are all of our samples for column store in memory, JSON, R services, reporting service, security, SQL bulk load, the VDI stuff. So in this case, if you go look at the JSON stuff and look at some of the script, this is the JSON script that was used for the Channel 9 videos that I'm talking about, where the engineering team actually explains how everything works. You can actually cut and paste this thing and use the examples. In fact, I might even have it here. Oh, there it is. OK. So here's the JSON sample. Declare JSON and varchar. There it is. All right. And let's just run this. So we have is JSON to validate. Yes, it is JSON, right? So we have these JSON functions that you can use. Now, again, there's not a lot of purpose for me to go through and show you this, but it'd be better if you actually went and did it yourself and play with the stuff that you're really interested in. But this sample shows all of the functions. So is JSON, JSON value, right? So it's a JSON type. The value here that we're looking at is Vlad. Vlad happens to be one of the PMs who works on this. Let's see. Let's see, when was Vlad born, right? 1968. So, and it just goes on and how you can make use of it. And then they also, in the samples, so this is the basic demo of JSON with all of the fields. And then if you go back to the samples, there's also some more interesting code, like a product catalog and to-do app, like full end-to-end apps written by the JSON team to display and showcase JSON. And you can just go and download it and play with it, right? So does that make sense? Is that an easier, better way than me showing you demos and pretend that I know everything? All right. So in the presentation, I've included the links, and the presentation is already posted. But even if you don't remember it, you just go to GitHub, Microsoft samples, boom, off you go. So we know a lot of customers who are building new apps that are using JSON. We are getting some feedback, but we'd rather have more feedback. So if you want to just go play with it, even if you have no intention of building an app and you find interesting things that you want to share, please let us know, right? You can go watch the Channel 9 video and post to that and say, hey, the stuff sucks, or the documentation, or any of the forums you find interesting. If nothing works, you can also just go Twitter and say, @SQL Server, pound JSON sucks, and the JSON team will pick it up. Yes? No. Yeah. Yeah, because it's not a native data type. Yeah. Yeah, you can. Yeah, I mean, it's just a varchar that's been stored, right? But in many cases, you may not even store JSON, right? You may want to just produce JSON from rows because some application that down the stream needs it, or that you're building an application that takes JSON as like an employee record, and so you can do easily turn the row to JSON, so you don't have to do the parsing yourself, right? Again, if you think that there's a lot of value in natively storing JSON, we'd be very interested in knowing what the scenarios are. Yes?
If you have a choice between JSON and XML, because I haven't worked with JSON for data exchange purposes, are you recommending JSON probably be the way to start going?
We try to stay out of those religious battles, but what I'm telling you is we see JSON being used everywhere at far more frequency than XML. We just call JSON the new XML, right? I mean, it has some stuff which is better and some stuff which is the same. But because a lot of things like, if you're going to have an app that deals with Mongo, right, then clearly you would want to produce JSON, right? Because it's just a lot easier to exchange JSON with those things than try to figure out how to teach the other side to parse XML. If you're just doing a SQL to SQL thing, or SQL to Oracle, and these things all support XML, sure, right? But the question is, what is the real exchange going to look like down the road? Yes? Yeah. Yeah, it's going to be stored as varchar, but there's a function that validates that it's valid JSON, right? Yeah. Yes. So that was the first example there. Is JSON? Yes, it is. So basically to validate that it is. Anyway, go play with the script. It's just a simple script. It doesn't require you to set up any big app or anything. And you don't even need to have a database because it's just all dynamic SQL, right? Just run it and play with it. If you want to see the real app, then you can go look at some of the JSON apps that they have, which is an end-to-end app with the front end and all of that, right? Okay, R service. This is a little. I think you all have seen this slide. R introduced in SQL 16. So it's the language for data science, modeling. It's a weird language, honestly. But I mean, for somebody who comes from T-SQL, or if you're a Python programmer and C, C++, it has some odd ways of doing things. But it is a very popular language. If you work around Wall Street and you don't know R, that you're probably not gonna have a lot of success, right? So we have the R server, which is a standalone server. You can buy Microsoft R server and install it on Windows or Linux, or you can buy SQL Server that comes with R. And the difference between SQL Server R and the standalone R is that in standalone R, somehow you have to get the data to the R server. With SQL Server, you can execute the R scripts inside the database. And for this to work, we had to go build an extensibility model for SQL Server so that it can deal with runtimes that are external, right? So R has a runtime, and now that runtime is available in SQL through the SQL extensibility model. In the old days, we had an extensibility model called CLR, right, that supports C#. That was a little more deeply integrated, right, with SQL. So now we're a little more careful about deep integrations, right? So instead, we have an extensibility model because it makes it a lot easier. Now, it's possible that people would want to upgrade their R server at a faster frequency than their database. So this is why we want to be able to allow people to have a little more delineated extensibility model. And with our extensibility model now built in R being the first runtime, which is now available in SQL, then you can imagine that there will be other runtimes that will be available in SQL. Like some data scientists really like Python because it's a fuller, more capable general purpose language that also works really well, right? So adding these languages to SQL in the future will be a lot easier for us because we can do it through our extensibility model, which we created for R. So as soon as this thing came out, we ran into two things. There's a population of data scientists that understand everything about R, but don't know anything about SQL. And then there's a population of database people who don't know anything about R. So we're working in both fronts to educate data scientists like the benefits of using SQL and R, and we're trying to educate database people about the benefits of doing intelligent apps and scores and modeling and being able to do the advanced analytics close to the data, as opposed to always take the data out of the database, ship it to somewhere else, do the models, do the scoring, right? That doesn't really work well. So those are the fronts we're working. So for example, we have a couple of people who are building some R scripts that will analyze the SQL telemetry to tell you the health of your SQL server, like the stats and all of that, as a way of introducing R to DBAs. So the first reaction isn't to turn the damn thing off, because it'll have some value for them. It's like, here's the memory usage trends and blah, 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 right? The R visualizations are enabled in SQL, so you can do the graphs and charts from R, right? Okay, so widely used, easy to bring and explore data, uncover insight, easy to create beautiful and unique data visualization, thriving open source community. The last part is true. There's so many R packages out there. You can pretty much do anything you want without actually having to go build models. So the site called CRAN is where you go to get all of your R wares, right? And people have built a lot of interesting models out there, which are freely available, and they're all open source. You can pick up. Most of them are MIT licensed, so you can just do whatever you want with it. Some of them are GPL, so you have to be a little more careful. But the benefit of it is somebody has already done the work. So for example, this stuff is not easy sometime, right? So you really do need the data scientists. But getting engaged with the community really does help. Let's use an example. If somebody makes a statement about, I don't know, this projector, and says, this is a cool projector, or this is a hot projector, is that a positive sentiment? Is that a negative sentiment? Are they saying something good about it, something bad about it? Well, humans kind of know from the tone and everything, right? But you really need computers to be able to say analyze sentiment, because every company that makes a product now wants to analyze what people are saying about their product and figure out if the sentiment is positive or not, right? Like cable companies, they probably don't have to work very hard. They probably know the sentiment about them is bad, right? Because it's a well-known thing. But other products, people want to know. So how do you do this? Well, somebody built a bunch of models, and they went and took all of the Amazon product reviews that's been written about, I don't know, millions of products that Amazon has sold, and then used that body of data to train the model so that they could accurately score a statement for being positive, negative, or neutral, right? And this stuff is out there. And so, if you're working with a company and somebody says, hey, I want to take all the Twitter stuff and I want any mention of our stuff, I want to know what they're saying, right? Well, you're not going to have like an army of people sitting there reading the Twitter feeds, right? You have to build a system that basically takes a Twitter feed, does the sentiment analysis, right? So something as simple as that, and then you get into more complicated things like preventive maintenance and fraud detection and health care analytics. But the key point being, there's a vast amount of knowledge out there, so you don't have to start from scratch. So recommendation would be to go play with this stuff. So the reason we think that having R inside the database is important is because, again, the data is valuable. The data needs to be secure. The data can't be handed around between data scientists and wherever they happen to be running stuff. And that's just the initial analysis work that people do. But once you have a model, and you've built your model, and you've trained your model, and your model is accurate, and then you want to use the model for actually getting work done, as in score things that happen in real time, then you need that as part of your application. So here's what people have been doing. Some data scientists will get some body of data at some company. Maybe it's maintenance work, maybe it's credit score, maybe it's healthcare, whatever. And then they go build a model. And they use R, and they did training in the model. And then they figure the thing out. And they hand it over to a bunch of programmers to translate this thing into a Java app. Because they know how to deploy a Java app alongside of a database, right? But they don't know how to take an R script and deploy it and make it an operational part of an application that runs all the time. The trouble is when you take an R model and translate it and rewrite it in Java, it's very error prone. And it always, it never really turns out the way you thought it would. And then every time you make a little change, or every time the model needs to be improved, then you have to go rewrite this work. So it's a really painful process. Now, in this model, the data scientists develop the model, and then you just load the model into SQL, and then you just call a stored procedure. And like anytime somebody inserts a row, you can go score it, right? And so it makes it really easy to operationalize these complicated scenarios. And that's one of the biggest benefits. And this is why you want the data scientists to think of SQL Server as an easy way, a tool which will help them deliver the labor of their, all the work that they do. And this is why you want the DBAs and developers that work on the databases to be receptive of that, right? And so bring these two worlds together. So you can use any of the R IDEs. So you can use the Microsoft R client, or you can use an R IDE to interact with SQL Server and write models and so on. You can also then deploy these models inside the database and execute them inside the database, right? And so the way stuff works is basically you have an idea, you have a concept, you develop the model, and then you train the model with data until you get to a point where the model is accurately predicting, and then you operationalize the model. Now, conceptually, you really understand this because you've probably been watching weather reports. I mean, somebody developed a model for predicting whether it's going to rain tomorrow or not, perfected that model with all of the weather inputs that they get from NASA and everywhere else, and then they built this model and put it in some application so some TV personality can push the button and say, is it going to rain tomorrow, right? And it's been operationalized because they report every morning if it's going to rain tomorrow or not, right? So that's a model that's been trained with the data, and then you use the new data every day to score, will it rain? Will it rain? Now, imagine that same thing, except in every other industry that you can think about, it being useful to predict something that's going to happen, right? Whether an engine failure, whether a heart failure, whether a pacemaker failure, all of those things where you can try to predict So this is the process. You develop a model, you train the model, you operationalize the model, and your app starts calling the model every day, every transaction, every whatever that you need. Make sense? Everybody good? So some of the scenarios in sales and marketing, so this is if you want to find a way to relate to it. So customer acquisition, cross-sell, upsell, loyalty programs, marketing mix. You know, you go and you buy stuff and they print, like at the grocery store, they print a pile of coupons for you. They really want to print the coupon that you would use. They really, really don't want to print a bunch of stuff that you will just throw away, have no interest in, right? It's a waste for us. So the grocery store really wants to figure out how they can print a coupon that would be useful to you because you would value it and then you go back, right? So they need to predict if the stuff is, right? So based on your past and based on your buying patterns and what you just bought right now, they'll print coupons, right? So some of them do it really simplistic. If I buy, I don't know, a 6-pack of beer, right then they offer me a coupon for next week to buy the same thing. Well, that's kind of a waste for them because, I'm going to buy the beer anyway. I don't need a coupon. So they really need to find a way to print a coupon that has value but is not a given, right? So those are the retail models that people try to figure out with the loyalty programs. This stuff has been going on since the early 90s with data warehousing and so on and so forth. And it's just getting more sophisticated as time goes by. Demand forecasting, it's really big, right? And the demand forecasting, if you just use history, it's never accurate, right? So you have to be able to do better than that. And just think about all the retailers that have sales after the holidays because they didn't manage to sell everything that they had prepared for the holidays, right? If you can forecast the demand so you don't have to have sales, right, then you'd be much better off. Finance, fraud detection, credit risk management, lifetime customer value, product recommendation, operations and workflows. This is where you get operational efficiency, predictive model for maintenance, and so on. So one of our customers actually they've implemented this using R. Vehicle loans. They happen everywhere. They're a very profitable business. And so a lot of people just use the FICO scores to figure out if you're worthy or not. But the thing is, that's very conservative. And people usually do really well with their car loans. So you can take a lot more risk in cutting a car loan than other kinds of loans like credit cards. But if you just go by the FICO, then you would not make the loans that could be potentially very profitable. Plus, there's a repossession of the car and so on. And so they're building new models, which doesn't just look at the FICO, right? To make more money by taking more risks, but reasonable risk for car loans. So they shove the data in the database. They have column store indices. The R in the database uses the scoring, gets the data, queries against the column store, gets the data, scores it, and then stuffs it into an in-memory table for really fast access because they do a lot of this. And then they have visualization through Power BI that basically shows the individuals and the aggregate and where things are working when their things are not working, right? And so this is a situation where they're using in-memory OLTP, they're using column store, and they're using R, right, to build this model. And this is what we call HTAP. High-speed fraud detection is another one. Again, this has to be done real time, so because nobody is going to wait for a credit card transaction to, 2 or 3 minutes or an hour, right? I mean, that they have to happen fast. So in this case, again, it's a mix of in-memory technologies shoving a lot of transactions through. So there's R. Now, I have a database, and I have deployed a model, and I can run T-SQL against this database and do some cool scoring. And then you start playing with it, and you start adjusting the parameters. It's, it kind of ends up being a little bit of a fun thing to do, at least for some people. Where is this database? So in this case, the model is actually it's a New York City cab prediction model. So let's do this. I'll go to the R samples. So again, GitHub, Microsoft, SQL samples and the features. And so the loan classification, we actually work with the customer, so we have a bunch of the stuff here. So you can actually go look at the code, how they do this. The SSMS custom reports that I was mentioning, it's all here. There's some code snacks, a little bits and pieces of code that you can go and play with. There's some telco churn models, loan classification. So if you look at the loan classification in the samples, it's very organized. And so you got 1, 2, 3, 4. Those are the steps. So if I was to do a demo, I would just follow those steps. But let's go look at it. So we create a database. We import a bunch of data. We create a column store so we can query. We create the model. Okay, so this is the creation of the model. And this is the little snippet of R that defines the model, right? And this is the select statement that sucks the data out that feeds the model. So then you create the model, and then you create a resource governance pool, so R runs and it governs. And then this is the scoring, which is PowerShell script that then you can call and look at this stuff, right? So there you are. All you need, SQL Server Developer Edition, you just copy paste the scripts in SSMS and execute them and go play with it. And you'll get familiar with R. And then you can look at some of the other more sophisticated stuff along the way. So hopefully this gives you an idea of why we think this stuff matters. If you're not an R fan and you're a Python fan or something other, but these kind of analytics stuff is going to be in our future, and we're going to make sure that the database plays well in this space. And we hope that you will go and build code that leverages this stuff for your business. I want to cover temporal a little bit. Anyone tried the temporal tables? Anybody knows about temporal? All right, so this is basically building a time machine for your database, right? And it makes life a lot easier for developers. So let me give you a scenario. If the HR person comes into my office and says, Tony, I want you to go and tell me what is our salary burden today. So I would go and run a sum on all of the employee salary and say, okay, we pay $5 million a month in salaries. And then the HR person says, well, what was it 3 months ago? Well, can you answer that? You run a sum on a salary column on a table from 3 months ago, and how do you do that? Well, you have to be able to do that because there are situations where auditors need to know, right? So in order for the developer to be able to answer what the salaries were 3 months ago, what are you going to do? Keep every copy of the table for every day? Create reports and print them and store them so you can answer the question? Usually people end up writing sophisticated code that records every change to the salary table and stores that data in a history table. So then you can write these crazy, gnarly queries and some programming logic to reconstruct the past and do it accurately so that you can answer the question, what was the salary burden 3 months ago? Well, it's not easy. It's difficult. So with temporal, basically, you define a temporal table, and the database does that work for you. So this is the time travel part. And there's some other scenarios as well, like slowly changing dimension tables, right? So you want to kind of know, what it was, and you want to be able to use a dimension table from the past, right? Whoops. So the way it works is, we have a 2011 ANSI compliant implementation of this. There's some DDL that allows you to create temporal table, and then you have your usual DML, and then you have your querying, and then you can have a temporal query. So this can be completely transparent to the application, right? Because all of the history and all of that temporal characteristics is managed by the database. If you have a regular table and then you define this to be a temporal table, the database will go and create the history behind it, right? And start to store all the versions and all the history and track the changes. So when you run queries, the database engine will do the reconstruction of what the history looked like and answer the question without you doing any work, right? You can, in SQL vNext, we also are introducing retention policies for your temporal. So like if the auditor says, what was the salary burden 3 months ago, you can answer, but you don't need to answer it for 30 years ago. So maybe you put a 7-year limit on your temporal table so that it'll automatically clean up after itself, right? Let me get to the interesting part. Very different. Yeah. Change data capture just captures the changes so that you could replicate the changes. But it doesn't reconstruct the history on a query, right? So with this, you can actually write a regular query to see what the answer was 3 months ago, right? So if you run, you do insert updates or whatever, your changes, and the changes then basically go to your version history table. And when you query, if the query is about now, then the data comes from your regular table. If you do historical queries, then the data will come from the history table or get reconstructed, merged with the current table if there are no changes, you get the right answer at the end of the day. So scenarios, automatic versioning, adding more throughput in existing temporal absences is the stuff we're working on. And pretty much if you work in any field where somebody's going to audit anything, this could be a very useful sort of a thing. Another thing is a lot of people just keep data forever and keep history forever. And it just makes everything slow all the time because you have to deal with the history. Being able to start using temporal stuff, you can keep because you don't lose the history, right? The changes are there and they're tracked by the database. So you can keep your working set smaller by having the temporal characteristics defined for the table. So this is what, and we also enabled this for in-memory tables as well recently, so works there. As you can imagine, if you have in-memory tables, you may want to keep them smaller because they are in memory. So you can define temporal tables for your in-memory tables, and to keep the in-memory table smaller but not lose the history.
Can you set your history table up on Stretch so you can archive it to the cloud?
Yes, but no, actually. You could use Stretch on your regular tables to start archiving the table, but you can't combine it with temporal because temporal needs to be, it doesn't understand history table that's been stretched. So they're very similar. but the performance characteristic is very different. A temporal query is much, much faster than a stretch query. Because a stretch query has to go out to the cloud far away, right? And I think with history, again, like if you were to calculate the salary burden, right, stretch doesn't really help you, right? Because you updated a row, right? It's not just some old rows that moved away. So you have to rewrite your app to keep every version of my salary row, right, and timestamp it. And you have to do that for everyone all the time. Again, it makes your application very complex. So achieving the same thing with stretch is a lot harder. In-memory history, right? Now, scenarios clear? All right, question?
So you have a table, and you have your employee information and your salary, and you have a 1-year retention. And now raises come, and everybody gets a raise, so your data is duplicated. One is live, one is a history part. How does that affect your storage? How does it typically?
So the question is, you have an employee table, you have salaries, and time of the year comes, and everybody gets a raise. And so a raise is an update of the salary column. So it's a change for a column. So my salary goes from $2.58 a day to $3.58 a day. That's the change which is stored in the history, in the temporal history. Right? It's not that we store everything, right? And then maybe we can reconstruct, right? So it tries to be very efficient. But if you have tables that are changing all the time, let's say you have 1,000 employees, there's 1,000 rows in the salary table. Well, that never changes. It's always 1,000 rows, or unless you hire a new employee. But over a 10-year period of time, of course, changes that have been made to those 1,000 employees, that the employees have come, employees have gone, right? Those are all recorded. So again, maybe 6 months ago, you had 900 employees, or maybe you had 1,200 employees, and then you had a reduction in force. So, the temporal query will answer the question based on whatever data was in that table at that time, right? So, and then you don't have to do that logic.
Your storage.
Well, you'll have to pay for the storage. Yeah, I mean, the data is there, right? The changes are there. It's, it tries to be very efficient, but it's stored. If you did it yourself, you would have to store the data as well. And I think chances are the database guys have figured out how to do that storage part as efficient as possible and balance it out with the performance, right? So how much work you have to do to reconstruct the history, right? That work, how fast can you do it, right? So we're trying to balance for storage and performance, but almost always favor performance because I don't think people are running out of disk space these days. I mean, sorry. So again, this is an entire little app that they've built with Temporal for product catalog. So again, you can imagine product catalogs change all the time. So here you'll be able to reconstruct. So if you're interested in playing with this, I would just say go get this Git depot and start playing with it. Right? Here's a demo, right? And the setup demo. You could run the setup demo on your machine. If there is data load needs, it's all part of that, and you can go play with it and see how it works. And then you can actually do space used to answer the question. So how much space is it using, right? Because you can tell on your machine what it's doing, right?
How does it handle encryption? So let's say
It just follows whatever the base table is. Yeah. So if the table is encrypted or compressed or whatever, right? It doesn't care.
you don't have to worry about rotating keys or anything like that because it stays still live data.
Yeah. The history is managed by the database You have no visibility. You know, it just deals with it for you, right? So it's not like some separate thing that you have to go deal with. And that's why we had to go and define a retention policy, right? Because you can't go mess with it, right? Okay, so you can go play with that stuff. This. Has anyone played with in-memory OLTP? All right, so this has been around for some time, since 2014. We've made some improvement. Because it was an E-only feature, not a lot of people wrote code for it. Now you can get in-memory tables in SQL Server Express Edition, which is free, right? By the way, Express is free. You can use it in production. A lot of times somebody will tell me, hey, I'm going to use Postgres because it's free. I'm like, have you considered SQL Express? And go, really, you have a free SQL server? The answer is yes. So what is good about in-memory? Well, it is for high performance, low latency, high throughput. And how do you achieve that? We go, well, what if I put all of my data on SSDs? And then they'll be fast. So why do I need in-memory? Well, if you put the data on SSDs, SQL Server still has to do file operations. The file operations will be fast because it's on an SSD, but it still has to do file operation. And the file operation requires a lot of instructions. And when you go off to do instructions, you have to do I/O, then you have to be very careful about locking semantics and transactionals, blah, blah, blah. So the database has to do a bunch of work just so it can go do an I/O. Even if the I/O is fast, you're still burning all the CPU and causing the concurrency issues because now you have to go do an I/O. When the stuff is defined to be in memory, it is in memory. The database knows it's in memory. It knows it's not going to get interrupted by an I/O thing, right? So it does a lot of different paths for in-memory than the traditional tables, which are on disk. And the performance improvements and the optimization comes from the fact that the database knows the stuff is in memory and it does things very differently. And so you can have latch-free, right? No locking, because the database basically controls things and manages the transactional stuff. And the stuff is in memory and it's fast. So putting stuff in a buffer cache and using lots of SSDs isn't exactly the same thing as using real in-memory objects, because it is both the access latency improvements as well as the code path reduction in dealing with in-memory objects. Along with in-memory, you could decide if you need stuff to be durable or not. And so what do we mean by that? Well, it is transactional for sure, but let's say you're managing website session information using in-memory tables. Sessions come and go, so you need to make sure that a session is consistent all the time. But if the SQL Server crashes or your website crashes, all the sessions are going to go away and they have to be reestablished. So having the session stuff be durable, maybe you don't care. So you can have an in-memory table which is transactionally consistent as long as the stuff is up, but it kind of behaves like a temp table. You can also, if you need temp table-like place, you could use a non-durable in-memory tables for really fast, high-throughput temporary access, which is transactionally consistent but not durable, as in it won't withstand a crash. You can also have durable ones, which basically says we make sure that anything happens, crashes or whatever, you come back and you still have all your data and it's transactionally consistent. Right? So we have both modes. And so one of them is, of course, much, much faster because it's a scratch space, right? So we think that a lot of applications will move to this, right? That over time, the disk stuff will become less and less and less. And you would only use disks or actually non-volatile memory to do the log device. And the rest of it will just live in memory. Memory is getting cheaper. So it solves a lot of problems. So that's one set of things. The other set of things is within memory. You can also use compiled code. So you can write stored procedures. And let's say you have a set of stored procedures that are called frequently, and they're very time-consuming or resource or consuming stored procedure, or you need them to have a very low latency. You can actually compile the stored procedures in native code so that it's not interpreted, right? And that also runs fast. So when you combine in-memory OLTP, which removes locking, removes a bunch of code path, gets rid of the I/O latencies, and run compiled code, that is the fastest thing you can get, right? Basically, it runs at the speed of machine code. So this is the stuff where initially when we came out with it in 2014, there were a lot of restrictions, like you can only have like 5 indexes on it, so people couldn't take lots of things and put it in memory. However, some customers who really needed it really got a lot of benefit from it. We have a customer, they're a gambling site, right? And you can imagine the traffic on a gambling site and the need, like the financial accuracy of a gambling site is more strict than a bank. Like bank might be able to lose a penny, a gambling site can't. So they use in-memory for these very high throughput scenarios, right? Because it's worth rewriting their app. But a lot of people are saying, I'm not going to rewrite my app no matter how fast it is. It's not worth it. So we've been working on removing some of the restrictions on in-memory OLTP, and we did a bunch of them in SQL 16, and you saw the list I had for SQL vNext will also have a bunch of improvements. So we think it's getting to a point where you can use it for a lot of general purpose stuff. Again, not a straight migration, but again, things that really need the performance, you should be able to really consider in-memory OLTP. Guess what? I have some samples for this as well. Again, on GitHub, there's a whole lot of samples for in-memory. Order processing, again, CodeSnack, T-SQL scripts, ticket reservation system. It's all these demos and apps that people built with in-memory technologies. So if you need examples and such, you can go, right? Or you can go download the whole thing, build the app, and start playing with it yourself to familiarize yourself with how it works. And then the nice thing, by the way, about these samples, like the person who posted this, Jos, he's a principal PM, he's been in the SQL org for many years. He's the guy behind the stuff, right? He works every day with a team of engineers for in-memory, right? So if you go to GitHub and you download the stuff and you find things which are confusing or things that you think could be better or whatever, you actually have the opportunity to post here, and Jos will get the email. And I don't think you can find any other way to get to the engineer who wrote the code to ask a question other than here, right? I mean, this is the best way to get engaged with the right set of people. Because I can guarantee you, if Jos doesn't know the answer about some in-memory thing, then probably nobody knows, and somebody has to go read the code, right? And every one of these samples are posted here by the people who really care about that. Like Jovan here is the temporal guy, right? You can go look at any of them. You'll find that it's actually the engineers who work on it. So it's a good way of engaging with them, right? So both for educational purpose and learning. And the reason I'm really going through this stuff instead of just doing demos, because we really do appreciate the engagement on GitHub, because it gives us some confidence that we're doing the right stuff, right? Okay. Connect to SQL. So what do you write code in? What languages do you use? C, C++, C#, Java, JavaScript, Python, PHP, right? The variety is pretty big. So what we've done is our goal is to make sure you can write code that connects to SQL and does whatever you need to do with SQL on whatever platform from any language. And that it's supported by Microsoft. So let's take Ruby. A lot of people like to write code in Ruby. It's not as popular as Python, but there is a very loyal group of people that work on Ruby. There's a guy who wrote a driver for SQL Server for Ruby. And then there's Ruby on Rails, which is the ORM, and lots of people use Ruby on Rails to write apps. And there's another guy who works on a Ruby connector for Ruby on Rails for SQL. So Ruby on Rails understands SQL Server as a backend for the ORM. So one of the things we did is we invited a bunch of open source people to Microsoft, and we offered them a bunch of engineers to sit with them and work on the backlog of their bugs for a couple of days, right? Just to get to know each other. And so we did this, so we improved the Ruby stuff, so now Ruby connectors work really well for SQL. And the open source community said, okay, Microsoft is serious about this stuff. They're not just, they're willing to actually do stuff, invest time. We also bought subscriptions to AppVeyor and Travis CI and wherever it is that they're doing tests so that we would help them to make sure that their test environment always includes SQL Server. And this was one of this group of people, and we also brought the Python folks, by the way. They were one of the people who told us, hey, if SQL Server was on Linux, it would make life a lot easier for us because all of our CI/CD environments is on Linux. So it's a lot easier to do continuous integration and builds. So now they're all using SQL as well. They're using SQL Server on Linux for their testing. For JavaScript, the driver is called TDS. Because it implements the TDS protocol. And we have engineers that hired by Microsoft that are working on it. We didn't start the TDS project. It's just a project that's been there. No, it was by other people. So we're basically investing in all of this. Open source the Java stuff, so there's a reference for everyone else who wants to write SQL drivers. So there's a full implementation of the entire SQL Server connectivity stack, including always encrypted and the protocol and everything. So you want to go and create a connector in some other language, you can just go rip off our Java code and copy it, right? And all of it under MIT license. So, and then we test these things all the time to make sure they work. So you can use any language from any platform to connect to SQL. I have a really cool demo, actually, that I was doing where I was connecting with one language and making changes with another language and querying with a different language. It's like I had 5 different languages in one app. But instead of doing that, I'm just going to walk you through this. So this is a website, aka.ms/SQLDev. So it's pretty easy to remember, aka.ms/SQLDev. We built this site. This site is built and managed by engineers. So this is not a marketing website. The content here is done by the engineers, so not the technical writers. And the idea was, if you walk up to SQL Server and you just want to write code, where do you start? So you start by your choices. First, you pick a language. Let's say you want to write Node. And then you pick up where are you going to write this Node thing on? Well, I want to write it on a Mac. OK, so you pick Mac. And this launches a tutorial that walks you through the entire thing. It has 4 steps, 1, 2, 3, 4. Well, sorry, 3 steps. And they get progressively more difficult. So the first step is, I want to write some JavaScript on a Mac to connect to SQL Server. Well, what do you need? Well, first thing, you need SQL Server on the Mac. So if you want to know how to install SQL Server on any platform, this is a pretty good place to come, right? So to install SQL Server on a Mac, we recommend that you use Docker images. So we have the Docker SQL Linux images. So you do a sudo docker pull. You pull the Microsoft SQL Server Linux Docker image. And then you do a Docker run. And then you're done. You have SQL Server running on the Mac. This is why it's so popular, Docker images, right? I mean, look, it's 2 lines, and you have SQL Server running. And then we show you how you can get By the way, the Mac comes with Ruby, so you can use Ruby to go curl the stuff. You install brew. We use all of the native commands for that. So people use brew to install stuff on the Mac, so we recommend that you use brew to install the Node stuff on the Mac. We give you the instruction. All of the instruction come with the copy button, so you can just copy and paste. We have a SQL CLI tool on the Mac for Node that you can use to connect like SQL CMD to SQL Server from a Mac using JavaScript. You install that, and then here you are. You can connect and select add version. So now you have SQL connectivity using Node, using a JavaScript connectivity tool on a Mac, and you can query your SQL Server. And then the second part of it is, okay, I want to write some code. So then we show you how to write code, and we give you the sample, like this is how you connect. This is written in JavaScript, right? And then you can connect and do stuff. And then we have some samples that does some CRUD, update, insert, so again, examples of that. And so you can basically create a table, install, insert rows, update rows, and so on, right? And all the samples are there, and you can copy, paste to get started. And then the last step, again, the samples, you can stop at any time, right? They just progressively get more complicated. Like, the first thing just connects and disconnects, and then it creates a table, and then does inserts, and so on and so forth. And then the last part of it is, what if I want to do something more interesting? So the last part is like shows you how you could use column stores and load data, and how column store queries are faster. And it basically gives you all the code necessary to do that. And so this is just a data generator, stuffs a few million rows in your database, and then here's the queries and so on, right? So this is the tutorial. And so if the assumption is when you walk up here as a developer, maybe you know everything about JavaScript, but you know nothing about SQL. So we try to make sure that as a person who doesn't know anything about SQL, you can go through. Maybe you're a SQL person and you know everything about SQL, but you don't know anything about JavaScript. That's why we go through the steps of showing how do you install Java and Node and all of that, right? Maybe you know everything about Node.js, and maybe you know everything about Mac, but you don't know anything about SQL. So we try to cover all of the various things so that you can easily get up and running, writing code for SQL, right? So this is the purpose of this website. Again, aka.ms. And we continue to add more. So there's an R, there's an R tutorial there. It's like, I want to do R. OK, R doesn't care. As long as you have SQL Server on anything, you can do the R thing. And so it shows you how to go build a predictive model. Again, it has the step-by-step instructions. You can copy, paste, and start playing with it. By the way, SQL Server was the database of the year as ranked by Database Engine this year, because our popularity increased more than any other database. In fact, in points, our popularity increased as more than, well, a little less than Oracle's popularity decreased, and we beat both MySQL and Postgres in improvement in our popularity. So it's kind of cool. So anyway, this is the connectivity and language tutorials for SQL and how do you connect. Each one of these tutorials that you go look, like I want to do Ubuntu and Java, and so each one of them has comments in the bottom, so you can go and say, hey, this worked or didn't work, or this was hard, make it easier, and so on. So we talked about security a lot in all of the other sessions, plus we had the lab, so I'm not going to spend a lot of time talking about the security stuff. There's a lot of tutorials around security. Again, you can go to GitHub and pick up all of the security examples for implementing data masking, always encrypted, and so on and so forth. But we look at security in this way, and this is the model, right? You have the access methods, you have the database access things, you have the encryption and monitoring and insight, right? So first, how do I secure the connection? How do I connect? How do I secure the data, like encryption and so on? And then how do I authorize access to an identified person? And there's a lot of features that we've introduced, but most interesting for developers is dynamic data masking, row-level security, and always encrypted. These were introduced in SQL 16. They're really easy to play with. The samples are really easy, like writing a policy for row-level security. You don't need much other than a few lines of SQL to experiment and play with. And again, I have all of that here. The samples were created by Jakub. Jakub is the one of the guys that works on security. So there's examples of how do I use Azure SQL DB with Active Directory. And the Contoso Clinic is a kind of an end-to-end app that allows you to do reporting, pretends to be a clinic. So then, it uses row-level security, always encrypted, and data masking as part of the app for its samples. And you can go look at the source, and you can look at the T-SQL scripts. It's like, how do you enable RLS? And there it is. So that's kind of a tour for developers, high-value features that we think you should really use, right? In-memory stuff, advanced analytics, the security features, temporal, and where to go to get started with this, and how to engage with Microsoft engineering teams that support these features so you can give us feedback or get help. And really just enable yourself to go and experiment, and do pick up SQL Server Developer Edition, install it wherever you want, and just play with it. And if any of these experiences you go try, you don't like or find it to be difficult, you know where to complain. And if none of that works, you can, again, use Twitter, say @SQL Server, @Tony Petrosian, you suck, and we'll get that message. So anyway, I'm going to stop here. Hopefully this was useful. A little non-traditional way of doing demos, but hopefully you got something out of it. And thanks a lot.